Hello students, in this class we will discuss depth first search graph traversal algorithm. In our previous class we discussed breadth first search BFS graph traversal algorithm. So here in implementation of this DFS or BFS algorithm, the major difference is the auxiliary data structure which we use. In previous class, in BFS breadth first search we used queue, and here in depth first search algorithm we will use stack. Other concepts are same, so it will be better if you have not gone through my previous lecture, you please go through that. So status of all the nodes initially is 0. Status of nodes, we are taking 3. I am reminding you 0, 1 and 2. 0 means they are not yet processed, nothing is done with them. Status will become 1 when a node is pushed on the stack, and when it is taken out of stack and appended to the output, status of the node will become 2. So 0, 1 and 2. 0 when nothing is done, 1 when pushed to stack, 2 when popped out from stack and pushed on the output. So let us start. We want to traverse this graph using stack. So what we do, we start from somewhere A. You can start from any node, but as I suggested you in exam, if not specifically said from start from this point, then you need to start always from A, so that you will be your answer will be having a shape of like other students, so examiner will not get confused. So here A you will start. So A is pushed to this stack. Its status will be set to 1. Now you repeat until the stack is empty. What to repeat and what to do? Pop 1 from stack. So one node, say it is U. So you are popping some node U from the stack, and it will put you will put it on the output. Its status will become 2. Now all the neighbors of the pushed popped node, so that is U node which you have popped out from here and put on the output, all the neighboring node of U having status 0 will be pushed on the stack. So that work you will do again and again. So here you see I have shown you the different steps. This is stack condition, this is output condition. So stack is having A, output is empty. What I'll do, I'll take 1 out from stack. So pop from stack. How to pop from stack? The LIFO condition, last in first out 4. So this one is A is out, taken out, it is on output now. So once it is on output, its status become 2, and now you will push its neighbors. So neighbor are C and D. So C and D will be pushed on this stack. So C and D in what order? Any order, whatever you like, you can push in any order. But when you'll pop, you need to follow the stack rule, LIFO rule. So C and D are pushed. This is output. Now what will I do? I will take 1 out from stack. So I will take D out from stack, and it will go on output. So output will become AD. And then neighbor of D. So neighbor of D are B, E, F, A also, but A is not having status 0. So B, E, F, E. So they are having status 0. These are pushed one by one to stack in any order. So I have pushed B, E, F. Their status will now change. They will become status 1. Now you will take F out of it, then output will become ADF. So all the nodes are covered here. So I am not now looking towards the neighbors, because there is no neighbor remaining having status 0. So ADF, then E will be taken out, ADFE, then B will be taken out, output will become ADFEB, and then finally C will be taken out to ADFEBC. So this is output of DFS algorithm. I hope it is clear to you. And if you face some problem, then you need to watch my previous video of BFS algorithm, because both the algorithms are having similar operation except their auxiliary data structure they use. So I have covered it little bit fast. Now here some home assignment for you. So you have already done, many of you have already done these assignments before I'm releasing this video, because this discussion was also taken in Google Classroom. So write algorithm for BFS and DFS graph traversal algorithm. See, this is important because in exams, sometimes you are asked to write algorithm. You are not given a graph to solve. So when you are asked to write algorithm, you need to write in formal way. So you can refer your book, Soam's outline, and take the formal book, this algorithm from there, how to write the algorithm in formal way. Then what are difficulties in applying BFS and DFS graph and traversal algorithm on directed graph? Comment. So this is a question which is not directly related to your course curriculum or syllabus, but you need to explore the internet. What are the difficulties when you apply BFS and DFS graph traversal algorithm on directed graph? So this is all about the traversal algorithms, BFS and DFS. Now we will discuss one new concept which is called minimum spanning tree of a given graph. So a graph is given and you are asked to find the minimum spanning tree of the graph. So before we discuss the algorithms for finding MST, minimum spanning tree of a graph, Kruskal and Prim's algorithms, we will see what is a minimum spanning tree. So purpose here in this class is only knowing, understanding what is a minimum spanning tree. We will discuss algorithms in next class. So before I discuss minimum spanning tree, let us see what is a spanning tree. So a graph GVE is given. See, I have told you earlier also, we write graph in this form G and then in bracket VE. So this denotes that V is set of vertices. Maybe like in this graph, vertices are A, B, C, D, E. So this is set of vertices is V, and E is set of edges. So edges are AB, AC, AD, BD, CD, CE, DE, like that. So you can put a list of edges in a set. So that set will be called E. And if we take mode of V, mode E, so in parallel lines you write V. So that will become number of nodes. So these are the standard nomenclature which are used in this graph theory. If you see somewhere mod V or mod E, then that is what? Number of vertices, mod V, number of edges, mod E. And V and E denotes the set of vertices and set of edges. So let us come back to our point. What is a spanning tree? See, in a graph, you can find many trees. What is the condition of a tree? There must not be a cycle. So see, this A, B, D and this. So this is a tree, T1. Another tree I can find out like this. So this is a tree out of this graph only. So these are edges. Some of edges I have selected, some of edges I have left, and there is no cycle in this. So this is also a tree. So this is a tree T2. Similarly, there is a tree T3. So this tree is having some of the edges I have taken from this graph, some of the edges I have left, and this tree is formed. So these trees are formed from this given graph. So from a graph, you can construct many different trees. T1, T2, T3. Now what you see in T1 and T2, all the nodes are not covered. But in T3, all the nodes are covered. So T3 is a spanning tree of this graph. Spanning tree of this graph. Because it is covering all the nodes. So a spanning tree of a graph G is a tree that covers all the nodes of graph G. So spanning tree, what is a spanning tree? It is a tree of graph G which is covering all the nodes. See, to become a tree, it is compulsory that there is no cycle. If there is a cycle, then it is not a tree. And if not a tree, then obviously not a spanning tree. So here in our example, T3 is a spanning tree of graph G. There can be more than one spanning tree of a graph. So you can see here in this graph, I have put some weight also. So this is a weighted graph. I can find many spanning trees. This is a spanning tree. This is also a spanning tree of this graph. This is a spanning tree of this graph. This is also a spanning tree, and this is not a spanning tree. It is covering all the nodes, but this is not a spanning tree. This can be called a subgraph, but it is not a spanning tree because it is having a cycle in it. So cycle is not undesirable condition. So this is not crossed just because it was wrong. This is crossed to show you that this is not a spanning tree due to cycle. And rest of these are spanning trees. So if you add up these weights, you will find that weight of this spanning tree is 12, weight of this spanning tree is 8, weight of this spanning tree is 11, weight of this spanning tree is 12, weight of this spanning tree is 11. You can see that we can calculate or sum up the edge weight for weight of spanning tree. So you can find many spanning tree of a graph, but their weight is different. So I hope that you are now getting the point. What is a minimum spanning tree of a graph? Minimum spanning tree of a graph is a spanning tree with minimum total weight. So MST of a graph, a minimum spanning tree of a weighted graph G is a spanning tree of graph G with minimum total weight. So this is the definition of MST. You probably have understood what is a MST of a graph. How to find MST? So we have two algorithms, Prim's algorithm and Kruskal algorithm, which we will discuss in the next class. Till then, you practice it, see the definitions, try to find out MST or spanning trees of a graph drawn by your